Hello, this is video for Math 2-3. This is about matrices. This is part 2. This video covers adding and subtracting of matrices. Given two matrices, please notice that they're the same size. They're both 2 by 2s. The question is, can we add them? And if we do, what happens? Well, the first thing we have to do is look at the size. It's important to note that this is a 2 by 2. And this is a 2 by 2. So the answer matrix, the matrix that holds the result of our addition, is also going to be a 2 by 2. We go cell by cell. So starting with the number that's in the first row and first column of the first matrix, we add that to the corresponding element or cell in the next matrix. It's really easy. It's as simple as it looks. 2 plus 1 is 3. You just add the cells together. So 3 plus 3, of course, is 6. 4 plus 2 is 6. And 5 plus 1 is 6. So the answer is this matrix right here. So if we can add two matrices, can we subtract them? I think so. If this is a 2 by 2 and this is a 2 by 2, it makes sense that the result is going to be a 2 by 2. And just as you might think, all we're going to do is subtract the elements. So 8 minus 3 is 5, 5 minus 2 is 3, 4 minus 2 is 2, and 1 minus 1 is 0. And you can have 0 as an element in a matrix. You just can't ever have nothing in there. You can't have a hole in a matrix like that. 1 minus 1 is not nothing. It's the number 0. So notice we have the same two matrices again as in the last example. And once again, we're going to subtract them. But this is important to note. Just like in ordinary subtraction, 2 minus 3 and 3 minus 2, those are not the same thing. This one, it comes out to be -1, and this one comes out to be +1, which are different numbers, even though they look similar, of course. Kind of the same thing happens with matrices. We've got a 2 by 2 minus a 2 by 2, so the result is going to be a 2 by 2. And we just subtract them. And we get -5, -3, -2, and 0 when we subtract term by term. Each of these elements of the result matrix are now negative. And it's a very similar looking matrix, but it's important to note that the -5 is not the same as a +5. What we're talking about here is something called the commutative property. This is a property that numbers have, ordinary numbers that we've seen before, like 5 plus 1 is the same as 1 plus 5. They both equal 6 on both sides. Addition has this property, this commutative property. However, subtraction, like we saw in the last example, 2 minus 3 is not the same as 3 minus 2. So subtraction does not have the commutative property. In other words, it's not the same in both directions. You get different numbers. It's the same with matrices. You can add them, and it doesn't matter the order, but subtracting does make a difference. So the commutative property is true for matrix addition, but not for matrix subtraction. We'll talk more about that when we get to some other operations. So here's two matrices that are not square. Remember the ones that we looked at before were both 2 by 2. If we have matrices that are, remember we always do the size we always do the size rows first, so there's 3 rows and 2 columns. And this one over here also has 3 rows and 2 columns. The sizes are the same. We can add them together, and the result is going to be a 3 by 2. Let's make that matrix. I always like to make the matrix first and figure out, well, I'm going to have 3 rows and 2 columns, so I'm going to have these spaces here. Now I'll just fill in the spaces. This helps me keep track of them, because when we get a lot of numbers going on at the same time, I can easily get lost. So 3 plus 6 is 9, 2 plus 2 is 4, 1 plus 1 is 2, 4 plus 5 is 9, 5 plus 7 is 12, and 2 plus 10 is 12. So there's the entries, the elements in the cells, in the 3 rows and 2 columns of the result matrix. We've got a special case when there's only 1 row. These are just plain old matrices, but they have a special name. This right here that only has 1 row but 2 columns, unsurprisingly I hope, it's called a row matrix. Now there are no special properties when you're adding these together. Since this is a 1 by 2 and this is a 1 by 2, we know that the result is going to be a 1 by 2. And you just add 2 plus 3 is 5, and 1 plus 4 is 5, and the result is another row matrix. If you only have 1 column but multiple rows, it's called a column matrix. So here we've got an example where, let's see, I guess we would take the first thing and add it with the first thing and the second thing, and you add it to the second thing, but what do you do with this guy right here? What do you add to the 7? The answer is you can't do it. These are not the same size. Since these matrices are not exactly the same size, this is a 3 by 2 and this is a 2 by 3, the difference can be subtle, but it's important. You just can't add them together. There's no way to do it. There is no answer. There is no solution to that problem. You just can't do it. Can you work with fractions? Yeah, of course you can. Just a couple easy points to notice about fractions. First off, when you add 1/2 and 5/2 together, it's not that tough. When you do it, you just have 1/2 plus 5/2 equals 6/2. But simplifying that into 3 makes sense in this case. Similarly, 3/2 plus 1/2 gives us 4/2. 4 plus 1/2 equals 4.5. Should we express that as a mixed number or as a fraction? Honestly, it really doesn't matter. But just as a clue, it doesn't matter. It's whatever your preference is. But in this case, the problem was given to us with improper fractions, so we should probably give the answer with improper fractions. So 4.5 is the same as 9/2. But again, it doesn't matter that much. It does matter with this. You would never give the improper fraction 4/2. Okay, maybe not never, but the cases are very, very rare. Maybe when you're working with probabilities. And can you add negative numbers? 1 plus -1, of course, that's not nothing. It's 0. To sum up, Matrices can be added or subtracted. It's not that difficult. It's as easy as it looks, really. Be aware that the answer might not be the same backwards and forwards. You got to pay attention to the commutative property, or the commutative property, some people pronounce it as. That means that one matrix minus another matrix might not be the same if you write them backwards. Matrices must be the same size. They have to be exactly the same size to add or subtract them. Sometimes there just isn't an answer. If the matrices are not exactly the same size, then you can't get an answer. You would write no solution as the answer. It just can't be done. And that is the end of adding and subtracting matrices.